Today we're going to look at the first derivative test, and this is going to be for finding relative extrema. So it's going to be our relative maxes and our relative mins. Those occur when our first derivative equals 0, right? Or when we're looking at a cusp or a corner. So at points like this, where we have a relative max, a relative min, something that's higher or lower than the values on either side of it. While we consider this, we're going to look at it in terms of the first derivative. So the first derivative is going to be negative when we're decreasing. So here we've got the first derivative is negative. It's going to be 0 when we're constant, and it's going to be positive when we're increasing. So bearing that in mind, this is where we've got those very definitions, right? When f prime, our first derivative is greater than 0, we're increasing. Where f prime is less than 0, we're decreasing. And when it's equal to 0, we're constant. So when we're looking for intervals where we're increasing and decreasing, we're going to find our critical numbers. And then we're going to test the value of the signs on either side, right? And this process of finding where we're increasing and decreasing lets us figure out where we have a relative max and a relative min, and if at that point is indeed neither of those things. So that is called the first derivative test. So for the first derivative test, we have to find our critical points, and then we have to look at the value of the derivative on each side of those critical points. So these critical points here, right, they have a slope of 0. So at those pink points, my derivative is equal to 0. We're testing the values on either side. So if we're decreasing and then increasing, we're going to have a relative min. If we're increasing and then decreasing, we're going to have a relative max. And then if our sign stays the same, we're going to have neither. So for these functions, we're going to do our I do in red, right? Our you do in yellow, and our we do in yellow and our you do in green. Bearing that in mind, we're going to look at number 5. So for each of these, we're going to estimate the intervals where we're increasing, decreasing, and I'm going to encourage us to put a bar under it where we think about what our first derivative is. So where is my relative max or relative min, that point where my slope is 0? Well, that's right here. So at -1, I've got a derivative equal to 0. On the left-hand side, as I go left to right, I'm going up. So this side, I've got a positive first derivative, and I am increasing. On the left-hand side, on the other side, as I go left to right, I'm going down, so I'm decreasing. And that means my first derivative is 0. Is less than 0. Yikes. All right, so let's go ahead and look at an actual first derivative test problem, which we go from an equation then all the way to this increasing and decreasing part. Right. However, if we wanted to write this as an interval, it's everything to the left, -infinity to -1 is increasing, and everything from on the right, -1 to infinity is decreasing. Okay, so like I said, moving on to the first derivative test, we've got 2 problems we're going to look at here. The first is considering the function f of x equals x squared minus 8x. Our first job is to find our critical points. And remember, critical points are going to be where our derivative equals 0. They are our candidates, all right, for max and min, for relative max and relative min. So we're going to find our derivative, and then we're going to set it equal to 0. So my derivative here, 2x minus 8. And then I solve that for when it equals 0, because when the slope or the instantaneous rate of change is 0, I have a candidate for relative max or relative min. So I've got x equals 4. Then I'm going to test values of the first derivative. On either side of the critical point. So like I did for that graph above, I'm going to make a number line for the derivative. I'm going to put my critical point of 4 on there. Now we just pick an x value on either side. So I could do f prime of 3 and f prime of 5. We're just looking to see what the sign is. So if it's positive or negative. So to the left of 4, we've got a negative first derivative, which means we're decreasing. And then if we check our right-hand side, we've got a positive first derivative, so we're increasing. So if we are going to write this, then we've got increasing from 4 to infinity and decreasing from negative infinity to 4. All right, so now we have to determine if it's if the critical point is a max, a min, or neither. I should add here that we're talking about relative max, relative min, or neither. So I should have written that, I'm sorry. So we're going from decreasing to increasing. So if we want to imagine we're decreasing, and then at 4, we're 0, and then we're increasing because we're positive. This point is going to be a relative min. Because we switched from a first derivative of negative to a first derivative of positive, so going down to going up. Now we've got a different function to consider. Negative 2x squared plus 4x plus 3. We do our derivative to find our critical points, and then we set it equal to 0. So we got a critical point at x equals 1. Then we need to make our number line for our derivative and test values on either side of our critical point, which is where our derivative equals 0. Right? So I could pick 0 because that's to the left. Plug that into my derivative. I get positive 4, so over here I've got a positive derivative, which means increasing. And then we test the other side, so I can pick 2 because that's to the right of 1. And I get a negative value, so my derivative to the right of 1 is negative, so I'm decreasing. So I've got my increasing interval first, which is from negative infinity to 1, and then I'm decreasing. from 1 to infinity. So we're thinking about in 3 going from a situation where we're going up, we're at 0, and then we're going down at this point. So if we're increasing, switching to decreasing, we've got a relative max. This is at x equals 1.